In this video, we're going to take a look at the six trigonometric ratios which come from right triangles and the relationships between the sides in a right triangle. And so let's see how we can find these six trigonometric ratios. So first, just to get an idea of what this is all about and why we can do this kind of trigonometry stuff, let's look at these two triangles. We have two right triangles here. They both have a 35-degree angle, so all their angles are the same, so they have to be similar triangles. And working with similar triangles in the past, we probably know that we can make proportions. So suppose we wanted to find this x value. Well, we could say, we know that the ratio of these two sides, x over 5, or let's actually say this is probably more like 5.1. Okay, so we have we know that if we take x over 5.1, that ratio would have to be the same as this number 5 over this 8.7. Okay, and if we solve that, we could figure out what x is. And notice we took this side that is all the way on the opposite side. This x was all the way on the opposite side from 35, and then we took the hypotenuse 5.1. That's where we got our ratio. And we did opposite over hypotenuse. That has to be equal to opposite over hypotenuse here. Okay, well, we could also say something like this. Let's say we wanted to find y. Well, we could say that this y over this 8.7, y over 8.7 would be equal to 4 over 5.1 from the right triangle. So this is kind of taking this close leg, which we'll call adjacent, and putting it over the hypotenuse. And that ratio has to be true, and if we solve this, we could figure out exactly what y is. We could do another ratio if we wanted to. We could take this 5, which is on the opposite side, over the y from that triangle, from the left-hand triangle, and that would have to be equal to whatever x is over 4. That would have to be equal. Now, right now we don't care about finding these, but notice all three of these should be true ratios. And so we're going to give it some names here. This ratio here, we're going to call the sine. Okay, this ratio of taking the opposite over the hypotenuse, x over 5.1. This ratio here, these are the cosine ratios. And this ratio over here, this is what we call the tangent ratio. So since these are similar, and any triangle that has a 35 and a 90 would be similar, these ratios would always be the same, whatever they happen to be. All right, and so we have some definitions here. Defining these three sides as the adjacent leg, as, let's see here, we've got the adjacent leg because that's connected to our angle that we're talking about, theta. And we have the opposite leg, that's all the way on the other side, and our hypotenuse, which is always opposite the right angle. So defining these three sides, we can define some special functions here, some special ratios, and that gives us the sine, and that we got from taking the opposite length over the hypotenuse, the cosine, which was the adjacent leg over the hypotenuse, and the tangent, which is the opposite over the adjacent. All right, and so by taking these ratios, we can find the sine, cosine, tangent, and we abbreviate them sin, cos, and tan. And they all have to do with this angle, a particular angle that's less than 90. And if we flip these around, we have some what we call the reciprocal ratios. And sine, when we flip sine around, the reciprocal, flip the hypotenuse and the opposite, we get cosecant, and that's hypotenuse over opposite. And when we flip cosine around, we get the secant, and that's the hypotenuse over the adjacent. And we flip around tangent, and we get the cotangent. So we take our opposite adjacent and flip it around, we get the reciprocal, adjacent over opposite, we call that the cotangent. And here's their abbreviations. So let's try working these out here. Let's say we have a right triangle here, and we want to find the 6 trigonometric ratios for the angle beta. This is the Greek letter beta here, and a lot of times when we're talking about angles, we name them with Greek letters as their angle measure. And so we have two sides, 5 and 7. We'd like to know what this other side is, so we might want to take a moment and figure that out. How can we figure that out? If you said Pythagorean theorem, you are right. So we have x squared plus 5 squared equals 7 squared. And so we say x squared plus 25 equals 49. And we can subtract 25 from both sides. And that should give us 24. Let's square root that. And simplifying the radical, because 4 goes into there, we have 2 root 6. All right, so this is 2 root 6 here. So now we have all three sides. So let's find our ratios. Okay, remember we're talking about angle beta. So how do these relate to angle beta? Let's take a moment and define those here. So we have this is the hypotenuse, of course, because it's opposite the right angle. This is the adjacent leg, the 5 is, because it's connected to angle beta. And this guy right here, this is the opposite. So with that in mind, let's find our ratios. We know the sine of beta is opposite over hypotenuse, as we have up here, opposite over hypotenuse. So that's just going to be 2 root 6 over the hypotenuse 7. And it's just a ratio. It's a fraction. We're going to leave it alone. Sometimes we might want the decimal value, but that's good enough. Cosine is adjacent over hypotenuse. So now we have adjacent, which is 5. That's coming from here, over the hypotenuse, which is 7. Then we have our tangent of beta, and that is opposite over adjacent. So the opposite leg is 2 root 6 all over the adjacent, which is 5. So opposite over adjacent. Then we have our reciprocal, and that is our, starting with our cosecant. Okay, now we're using beta here. This is theta. It's just a Greek letter. That's just a name for an angle. Call it whichever you want. So, again, we just flip around the sign to get the cosecant. And it's useful to remember that the sine and the cosecant are reciprocals. It makes it really easy for finding the cosecant once you get the secant, or the sine. And the cosine gives us the secant. So the secant ratio is 7 over 5. And the tangent ratio gives us the cotangent. Or we can go back to the definition. If you want adjacent over opposite, that's 5 over 2 root 6. And right now you might notice we're not worried about rationalizing the denominator. Sometimes we will, especially with our special angles, but right now this is going to be fine. Some textbooks, some teachers will want you to, so just look for the instructions, and if they say simplify, you'll need to rationalize the denominator. All right, so there you have it. That's how we can find them if we know the sides. Now let's look at another type of application here. Here's a little twist on our trig ratios. We have a cotangent given to us. What if we know the cotangent of theta is equal to 7/8? Well, let's think about what that means. We know that cotangent of theta is the reciprocal of tangent. Tangent is opposite over adjacent. So this is adjacent over opposite. If you go back to our definitions, that's what we have. So that means that our ratio of 7/8 tells us something about our triangle. So it's useful to draw this triangle. Okay, we have our angle theta, and this is telling us that the adjacent is 7, the adjacent leg, that is. The opposite leg is 8. I didn't draw this very well to scale, but it's just a model, so that'll be okay. So, since that's true, we want to find the other ratios, so we're going to need to know what is this hypotenuse here. So let's do a little Pythagorean theorem. 7 squared plus 8 squared equals x squared. And so we've got 49 and 64. And that gives us 113. And that's just going to give us the square root of 113. Cannot simplify that, so we'll leave that alone. Alright, and so now we can find our trig ratios. The sine of theta is opposite over hypotenuse, sorry about that. Opposite over hypotenuse, 8 over the square root of 113. Cosine of theta, 7 over the square root of 113, because it's adjacent over hypotenuse. Tangent of theta, well, that's opposite over adjacent, 8 over 7, which we might notice is also the reciprocal of our cotangent. Well, that's good. That's what we expect. And then our reciprocals, we have cosecant of theta. It's going to be square root of 113 over 8. We have the secant of theta, and the square root of 113 over 7. And the cotangent, which we already kind of know, but I'll throw it in here. 7/8. And there's our 6 ratios. All right. And so that's how we find them, use the ratios using the sides of a right triangle. And in the next video, we'll take a look at how we can find missing sides and if we know the angle. And if we don't know the angle, we'll find out how we can figure out exactly what this angle is using our trig ratios and our calculator. So there you have it, and have fun finding your trig ratios.